My software cut off toward the end of that clip. Fortunately, I got most of it. I don't remember what we were going to see. Don't remember what I said next. But I think we were going to go off and talk about the transient term. We'd already seen how the energy of the system limits how big this can be. This first term, the transient term, is transient simply because we have an exponential with a negative coefficient of t, and the bigger the value of delta, the more quickly this thing is going to decay. So we have oscillatory behavior at a frequency that's at least a little bit less than the natural frequency. We have an exponential attenuation, so that the bigger the value of delta, the faster this thing decays and becomes irrelevant. And of course, the bigger the delta, the more the angular frequency of this oscillation differs from the frequency of this oscillation, which means these oscillations will tend to go in and out of phase at a more rapid rate, but that this will decay more quickly, resulting in a short transient phase during which the behavior might be sort of complicated, but that's going to quickly move over into just this behavior. Now, the value of delta also affects the coefficient over here. The closer delta is to omega naught, and of course that means delta is going to be larger. Again, the faster the transient will decay. And forgive me if I'm being a little hesitant here. I'm trying to, at the same time, remember what I said before, but say what I mean to say now. And I should forget that I said anything before so that I can simply discuss this a little more fluently. In any case, as delta gets closer to omega naught, the decay is faster, but these coefficients can be bigger. Now this coefficient depends on V naught. Remember, V naught is the speed I give this thing. I got this oscillator, I give it a kick, and it starts oscillating. Or at least it starts moving away from its equilibrium position. If I give it a large kick, it'll move fairly rapidly from its equilibrium position. And if delta is close to omega naught, as delta approaches omega naught, this actually approaches infinity. But of course, decays quite rapidly. This term can also be large if delta is close to omega naught. As before, there will be some range of values of t where the amplitudes of these two solutions are comparable, and you'll have beat-like behavior. But I'm not going to say a whole lot more about that. We're going to look next at what happens if delta is bigger than omega naught.